Welcome. This is group number 33 and myself Prajwali Rapa here. So let me give what the problem statement is. So the problem is we have to predict if an SMS is a spam or ham, which is a normal message. So what is SMS in the first case? SMS is nothing but a short message services, which is well-known form of communication service. So lessening where did this problem arise is because of the lessening of the cost of SMS benefits from telecommunication companies has prompted the utilization of SMS into many other things. For example, advertisement, promotion, etc. SMS spam is nothing but an unwanted messages sent electronically and whose content may be malicious, like their damages are like undesired advertisement or exposure to private information or like being loaded into a malware website or anything. So the steps we have used to come up with the solution is first we take something like 5600 data sets of records, and then we do data pre-processing, which includes like data cleaning and EDA. And we have tried many classification, out of which we had done some research about many classification, out of which we selected six better classifiers while checking the precision and the accuracy which they are giving, and at the end we launched a website using Streamlit. So now one of my teammate will continue.
Hi, this is Kumar Love, and I am going to explain you about the data cleaning process. Basically, data cleaning is the process of fixing or removing incorrect, corrupted, or formatted incomplete data within a given data set. When combining multiple data sources, there are many opportunities for data which can be duplicated or mislabeled. So here comes the role of process called data cleaning to correct these formatted, duplicated, or incomplete data. It plays a significant part in building a model. There are several steps which are involved in data cleaning, that is, removal of unwanted observations, fixing structural errors, managing unwanted outliers, and handling the missing data. Now, I am going to explain data cleaning and EDA from the given code. Data.info reads the column of the given dataset. Then we rename the column v1 as type and v2 as message. In the next step, we are dropping the unwanted columns unnamed 2, 3, and 4 and which are having majority null values. Afterwards, from sklearn.preprocessing library, we are importing label encoder to replace spam and ham with 1 and 0 values respectively as shown in the next step. Then we check for the missing values and duplicate values in the next two steps and removing them by dropping it using data.drop. Now checking if duplicates are removed or not and displaying the number of ham and spam by data.shape in the format of rows and columns. Now here comes EDA, exploratory data analysis. Here we count spam and ham messages. Now, by using pie chart from matplotlib library, we are showing percentage of ham and spam messages. Then from NLTK library, natural language processing library, we count the number of characters, words, and sentences of the sample messages using character count, word count, and sentence count variable in the next three steps. Here are the steps: character count, word count, and the sentence count. Further, moving plotting hist plot of character count using Seaborn library of spam and ham messages, ham as 0 and spam as 1. Similarly, for word count, we are plotting hist plot. You can see we have plotted the hist plot for both character count and the word counts in the same graph. Now after plotting, now from here Priyanka will be taking on.
Hi, this is Priyanka and I'll be explaining about data pre-processing. So data pre-processing is a process of preparing the raw data and making it suitable for a machine learning model. It is the first and crucial step while creating a machine learning model. When creating it, It is not always a case that we come across the clean and formatted data. And while doing any operation with data, it is mandatory to clean it and put in a formatted way. So for this, we use data pre-processing task. In this project, we use lemmatization, which is a normalization technique used in natural language processing that switches any kind of word to its base root mode. Now I'll be explaining code. So here we will be importing NLTK library to use necessary functions. Here we will convert every word into a token and then remove the stop words and punctuations. And then we will be lemmatizing the word and then checking if it's done. Now we will create a new data frame in which a new message will be there as SMS. uh, and then we will be counting the word, character and sentence count and then display it in the graph, that plot. And now we will be uh, plotting the another graph, like it's the same graph, just appearance wise different, to checking the number of words occurring how many times. So this was pre-processing, and now my teammate will follow.
I'm Vasu Jain, and I'll be taking the topic of model building for our project SMS spam classifier. So in this project, we are using 6 models as classifiers, namely SVC, KNN, random forest, extra tree, naive Bayes, and XGB. So we will be taking a look at each and every model briefly. So here we go. So first is the SVC. It is a supervised machine learning algorithm typically used for classification tasks. SVC works by mapping data points to a high dimensional space and then finding the optimal hyperplane that divides the data into 2 classes. Here our objective is that the hyperplane should be such that it is at a minimum distance from both the data points so that we can get an optimum hyperplane. And this way the classes are assigned to all the data points. Next we are having random forest. So in random forest, it is an algorithm consisting of many decision trees. It uses bagging and feature randomness when building each individual tree to try to create an uncorrelated forest of trees whose prediction by committee is more accurate than that of any individual tree. Next, we are having extra tree classifier. Extra tree is like random forest in that it builds multiple trees and splits nodes using random subsets of features, but with 2 key differences. Firstly, it does not bootstrap observations. That means it does not randomly choose without replacement. It chooses randomly but not without replacement. And nodes are split on random splits, not best splits. So now I'll be explaining a bit of a code. Let's go. So here we are with the code. So first of all, we are importing libraries of count vectorizer and IDF IDF. The purpose of these libraries are to change the text into vectors, as it is easier for our model to deal with vectors rather than text. So here in these steps, we are applying these libraries to these data frames where we have lemmatized the sample messages. After that, you can see the output. It has converted the messages into such vectors, and you can see such details that by finding the shape and other details, we have come to conclusions. Thank you. I will request children to take over.
Myself Srijan. Now I'll be explaining the KNN classification. In KNN classification, we have a new data point, and from the new data point we calculate equivalent distance with each and every data point which is existing in the data, and then we take top k points which have the lowest equivalent distance with the new data point, and in this we check which has the higher category. If category A points are higher in the k points, then we give the new data point is assigned to category A, otherwise assigned to the category B. Now let's go on to the next classifier, that is the naive Bayes classifier. In naive Bayes classifier, we find the likelihood of the new data point with each and every attribute, and we also find the probability of each and every attribute which is present in the set, and also the total probability of the data points. And now we, as per the formula in the given in the slides, we check the posterior probability of each and every point with the attributes. And now as we get highest probability for each for given attribute, if attribute 1 has the highest posterior probability, we get the data point to attribute 1. Otherwise, it's given to the other attribute which has the highest posterior probability. Now let's go on to the next classifier, that is the XGB classifier. In XGB classifier, we make trees for the data set we have. And now making these trees, we try to reduce our error. And now in this XGB, it's not the normal tree classifier. In this, we try to boost the classification. So we try to reduce the error by adding the next tree and keep on reducing. This is parallel tree boosting. Now let's go on to the code and understand the code. We have divided X and Z into training and testing data. As explained by Vasu, X is the TF-IDF array and the Z is as per the count vectorization array. And now we can check the imported files. We have imported all the classifiers here given below, and we have made a module for them. And then we have defined a function. In this function, we are using each and every classifier and fitting it to the training data. And then we predict the the value y using the testing data for the given classifier. And then we find the accuracy score, precision score, and the confusion matrix of each and every classifier. And then given below, we check the accuracy and the precision for each and every classifier in TF-IDF format and in count vectorization format. And then we get the output given below, and also with the confusion matrix as we had used the function above. And now we can see we have also made a tabular form of the same thing. This makes it easy for us to understand which model has the best accuracy and precision and in which type, TF-IDF format or in the CV format. Now as we can see in this, binomial naive Bayes has the highest accuracy and precision in the TF-IDF format. So we'll use this for functioning, and we'll predict whether the message SMS is spam or ham using the Bernoulli's thing. Now we have made two files using the pickle for the website that will help us in using the website. In this we have used TF-IDF, and we have made a file of the vectorizer and also another file of the model. The model is Bernoulli and the vectorizer is TF-IDF. Now I would hand it over to Neha.
Thank you, Srishan. I am Neha. My roll number is Big21109. Here I'll be talking about the website designing which was used for deployment. So first we have imported the pickle library which is used to convert the vectorizer and the best model which we found in the code into file formats. Later here we are using Streamlit, which is an open source app framework in Python for making the app. I'll be demonstrating how we have made the app and how the app works. Here I'll be explaining the code which I have written for making the app. So first we have imported both the files which we have saved in pkl format. Here model.pkl and vectorizer.pkl, we have imported both the files, and we are importing some of the libraries which are required, and we are also downloading some of the packages from NLTK. And here we are creating an object which is called elementizer, which is going to elementize. So this is the same function which was used in data preprocessing for returning a elementize statement, and the function is again going to give the elementize statement. Here we're just opening the files which we have downloaded, and then we are titling the app, and this function will return whether the given input is a spam or ham. So if the result is 1, it's going to print the output as spam, else it's going to print it as not spam. So here in the terminal, if we run this particular code, we are going to get the app directly on the browser. Here we are going to give a small demo of the website, how it works. So here I'm going to paste a message. As you can see, this is actually a spam message. So we'll see what it's going to print it as. Yeah, so we got the right answer. It was a spam message and we got the output to be spam. Checking spam detection is essential as it makes sure that the reviews given on the online stores are fair enough, and it would maintain the trust of buyers. And all the algorithms which are developed so far have not been able to nullify the need for manual checking of the reviews, because we can't really say which is actually a fair review or like a true review or a fake review. So, and the spammers are also getting smarter day by day, because it's getting really hard to actually classify these spams on the reviews. So there's actually a good scope for spam detection system with high efficiency. And the conclusion would be that it is necessary to identify the spam in order to develop counter algorithms to detect these reviews and other similar things. So this document has highlighted about the existing spam detection technique and its current application, but it is also showing that even the existing techniques have some drawbacks, and not all the methods are completely effective. So detecting review spam is a difficult task, but it requires continuous research and development in this field. By this, we would like to end our presentation. Thank you.